A coastline or a seashore is the area where land meets the sea or ocean, or a line that forms the boundary between the land and the ocean or a lake. A precise line that can be called a coastline cannot be determined due to the coastline paradox. The term coastal zone is a region where interaction of the sea and land processes occurs. Both the terms coast and coastal are often used to describe a geographic location or region, for example, New Zealand's west coast, or the east and west coasts of the United States. Edinburgh, for example, is a city on the coast of Scotland. A pelagic coast refers to a coast which fronts the open ocean, as opposed to a more sheltered coast in a gulf or headlands and bays. A shore, on the other hand, can refer to parts of the land which adjoin any large body of water, including oceans and lakes. Similarly, the somewhat related term, stream bed, bank, refers to the land alongside or sloping down to a river or to a body of water smaller than a lake. Bank is also used in some parts of the world to refer to an artificial ridge of earth intended to retain the water of a river or pond. In other places this may be called a levee. While many scientific experts might agree on a common definition of the term coast, the delineation of the extents of a coast differ according to jurisdiction, with many scientific and government authorities in various countries differing for economic and social policy reasons. According to the UN Atlas, 44% of people live within 150 kilometers of the sea formation. Tides often determine the range over which sediment is deposited or eroded. Areas with high tidal ranges allow waves to reach farther up the shore, and areas with lower tidal ranges produce deposition at a smaller elevation interval. The tidal range is influenced by the size and shape of the coastline. Tides do not typically cause erosion by themselves. However, tidal bores can erode as the waves surge up river estuaries from the ocean. Waves erode coastline as they break on shore, releasing their energy. The larger the wave, the more energy it releases and the more sediment it moves. Coastlines with longer shores have more room for the waves to disperse their energy, while coasts with cliffs and short shore faces give little room for the wave energy to be dispersed. In these areas, the wave energy breaking against the cliffs is higher, and air and water are compressed into cracks in the rock, forcing the rock apart, breaking it down. Sediment deposited by waves comes from eroded cliff faces and is moved along the coastline by the waves. This forms an abrasion or cliffed coast. Sediment deposited by rivers is the dominant influence on the amount of sediment located on a coastline. Today, riverine deposition at the coast is often blocked by dams and other human regulatory devices, which remove the sediment from the stream by causing it to be deposited inland. Like the ocean which shapes them, coasts are a dynamic environment with constant change. The Earth's natural processes, particularly sea level rises, waves and various weather phenomena, have resulted in the erosion, accretion and reshaping of coasts, as well as flooding and creation of continental shelves and drowned river valleys. Environmental importance. The coast and its adjacent areas on and offshore are an important part of a local ecosystem. The mixture of fresh water and salt water in estuaries provides many nutrients for marine life. Salt marshes and beaches also support a diversity of plants, animals and insects crucial to the food chain. The high level of biodiversity creates a high level of biological activity, which has attracted human activity for thousands of years. Human impacts. Human uses of coasts. More and more of the world's people live in coastal regions. Many major cities are on or near good harbors and have port facilities. Some landlocked places have achieved port status by building canals. The coast is a frontier that nations have typically defended against military invaders, smugglers and illegal migrants. Fixed coastal defenses have long been erected in many nations, and coastal countries typically have a navy and some form of coast guard. Coasts, especially those with beaches and warm water, attract tourists. In many island nations such as those of the Mediterranean, South Pacific and Caribbean, tourism is central to the economy. Coasts offer recreational activities such as swimming, fishing, surfing, boating, and sunbathing. Growth management can be a challenge for coastal local authorities who often struggle to provide the infrastructure required by new residents. Threats to a coasts also face many human-induced environmental impacts. The human influence on climate change is thought to contribute to an accelerated trend in sea level rise which threatens coastal habitats. Pollution can occur from a number of sources: garbage and industrial debris, the transportation of petroleum in tankers, increasing the probability of large oil spills, small oil spills created by large and small vessels, which flush bilge water into the ocean. Fishing has declined due to habitat degradation, overfishing, trawling, bycatch and climate change. Since the growth of global fishing enterprises after the 1950s, intensive fishing has spread from a few concentrated areas to encompass nearly all fisheries. The scraping of the ocean floor in bottom dragging is devastating to coral, sponges and other long-lived species that do not recover quickly. This destruction alters the functioning of the ecosystem and can permanently alter species composition and biodiversity. Bycatch, the capture of unintended species in the course of fishing, is typically returned to the ocean only to die from injuries or exposure. Bycatch represents about a quarter of all marine catch. In the case of shrimp capture, the bycatch is 5 times larger than the shrimp caught. It is believed that melting Arctic ice will cause sea levels to rise and flood coastal areas. Conservation. Extraordinary population growth in the 21st century has placed stress on the planet's ecosystems. For example, on St. Lucia, harvesting mangrove for timber and clearing for fishing reduced the mangrove forests, resulting in a loss of habitat and spawning grounds for marine life that was unique to the area. These forests also help to stabilize the coastline. Conservation efforts since the 1980s have partially restored the ecosystem. Types of coast. According to one principle of classification, an emergent coastline is a coastline which has experienced a fall in sea level, because of either a global sea level change, or local uplift. Emergent coastlines are identifiable by the coastal landforms, which are above the high tide mark, such as raised beaches. In contrast, a submergent coastline is one where the sea level has risen, due to a global sea level change, local subsidence, or isostatic rebound. Submergent coastlines are identifiable by their submerged, or drowned, landforms, such as reefs and fjords. According to a second principle of classification, a concordant coastline is a coastline where bands of different rock types run parallel to the shore. These rock types are usually of varying resistance, so the coastline forms distinctive landforms, such as coves. Discordant coastlines feature distinctive landforms because the rocks are eroded by ocean waves. The less resistant rocks erode faster, creating inlets or bays. The more resistant rocks erode more slowly, remaining as headlands or outcroppings. Other coastal categories. A cliffed coast or abrasion coast is one where marine action has produced steep declivities known as cliffs. A flat coast is one where the land gradually descends into the sea. A graded shoreline is one where wind and water action has produced a flat and straight coastline. Coastal landforms. The following articles describe some coastal landforms. Cliff erosion. Much of the sediment deposited along a coast is the result of erosion of a surrounding cliff or bluff. Sea cliffs retreat landward because of the constant undercutting of slopes by waves. If the slope, cliff being undercut, is made of unconsolidated sediment, it will erode at a much faster rate than a cliff made of bedrock. A natural arch is formed when a sea stacks is eroded through by waves. Sea caves are made when certain rock beds are more susceptible to erosion than the surrounding rock beds because of different areas of weakness. These areas are eroded at a faster pace, creating a hole or crevasse that, through time, by means of wave action and erosion, becomes a cave. A stack is formed when a headland is eroded away by wave and wind action. A stump is a shortened sea stack that has been eroded away or fallen because of instability. Wave-cut notches are caused by the undercutting of overhanging slopes, which leads to increased stress on cliff material and a greater probability that the slope material will fall. The fallen debris accumulates at the bottom of the cliff and is eventually removed by waves. A wave-cut platform forms after erosion and retreat of a sea cliff has been occurring for a long time. Gently sloping wave-cut platforms develop early on in the first stages of cliff retreat. Later the length of the platform decreases because the waves lose their energy as they break further offshore. Coastal features formed by sediment. Coastal features formed by another feature lagoon, salt marsh. Other features on the coast. Coastal processes. The following articles describe the various geologic processes that affect a coastal zone. Wildlife. Animals. Some of the animals live along a typical coast. There are animals like puffins, sea turtles and rockhopper penguins. Sea snails and various kinds of barnacles live on the coast and scavenge on food deposited by the sea. Most coastal animals are used to humans in developed areas, such as dolphins and seagulls who eat food thrown for them by tourists. Since the coastal areas are all part of the littoral zone, there is a profusion of marine life found just off coast. There are many kinds of seabirds on the coast. Pelicans and cormorants join up with terns and oyster catchers to forage for fish and shellfish on the coast. There are sea lions on the coast of Wales and other countries. Plants. Coastal areas are famous for their kelp beds. Kelp is a fast-growing seaweed that grows up to a meter a day. Corals and sea anemones are true animals, but live a lifestyle similar to that of plants. Mangroves, sea grasses and salt marsh are important coastal vegetation types in tropical and temperate environments respectively. Coastline statistics. Coastline problem. Shortly before 1951, Lewis Fry Richardson, in researching the possible effect of border lengths on the probability of war, noticed that the Portuguese reported their measured border with Spain to be 987 kilometers, but the Spanish reported it as 1,214 kilometers. This was the beginning of the coastline problem, which is a mathematical uncertainty inherent in the measurement of boundaries that are irregular. The prevailing method of estimating the length of a border was to lay out n equal straight line segments of length with dividers on a map or aerial photograph. Each end of the segment must be on the boundary. Investigating the discrepancies in border estimation, Richardson discovered what is now termed the Richardson effect. The sum of the segments is inversely proportional to the common length of the segments. In effect, the shorter the ruler, the longer the measured border. The Spanish and Portuguese geographers were simply using different length rulers. Richardson had believed, based on Euclidean geometry, that a coastline would approach a fixed length, as do similar estimations of regular geometric figures. For example, the perimeter of a regular polygon inscribed in a circle approaches the circumference with increasing numbers of sides. In geometric measure theory, such a smooth curve as the circle that can be approximated by small straight segments with a definite limit is termed a rectifiable curve. Measuring a coastline more than a decade after Richardson completed his work, Benoit Mandelbrot developed a new branch of mathematics, fractal geometry, to describe just such non-rectifiable complexes in nature as the infinite coastline. His own definition of the new figure serving as the basis for his study is, I coined fractal from the Latin adjective fractus. The corresponding Latin verb frangere means to break, to create irregular fragments. It is therefore sensible that, in addition to fragmented, a coastline is perceived as base-alternating with promontories. In the hypothetical situation that a given coastline has this property of self-similarity, then no matter how greatly any one small section of coastline is magnified, a similar pattern of smaller bays and promontories superimposed on larger bays and promontories appears, right down to the grains of sand. At that scale the coastline appears as a momentarily shifting, potentially infinitely long thread with a stochastic arrangement of bays and promontories formed from the small objects at hand. In such an environment, Mandelbrot asserts, coastline length turns out to be an elusive notion that slips between the fingers of those who want to grasp it. There are different kinds of fractals. A coastline with the stated property is in a first category of fractals, namely curves whose fractal dimension is greater than 1. That last statement represents an extension by Mandelbrot of Richardson's thought. Mandelbrot's statement of the Richardson effect is, where L, coastline length, a function of the measurement unit, epsilon, is approximated by the expression f is a constant and d is a parameter that Richardson found depended on the coastline approximated by L. He gave no theoretical explanation, but Mandelbrot identified d with a non-integer form of the Hausdorff dimension, later the fractal dimension. Rearranging the right side of the expression obtains, where f epsilon d must be the number of units epsilon required to obtain L. The fractal dimension is the number of the dimensions of the figure being used to approximate the fractal. 0 for a dot, 1 for a line, 2 for a square. D in the expression is between 1 and 2, for coastlines typically less than 1.5. The broken line measuring the coast does not extend in one direction nor does it represent an area, but is intermediate. It can be interpreted as a thick line or band of width 2 epsilon. More broken coastlines have greater d and therefore L is longer for the same epsilon. Mandelbrot showed that d is independent of epsilon.